Hello students, welcome back. Let us solve one more problem from Zettili book, Quantum Mechanics Concept and Application. And this is chapter 5, exercise 5.1. These are very important commutation relations. So we need to calculate position operator with angular momentum operator. So let us first calculate y. So y. So now y you know, in terms of momentum and position vector operator, if y is there, so z will come, z, and after z, x will come. Similarly, this will become p z. This is a linear symmetric relations. Okay. So Lx, how do you write? You write Lx after x, y will come. After y, z will come, and then z, py. Similarly, you have a y is there. After y, z will come. After z, x will come. And then again, you write pz. And similarly, you have a z. So x will come, then py, and then y, and then you have a px. These are symmetric relations. So here you see y commutes with z, y commutes with px, y commutes with x, y commutes with pz. So this whole commutator will become 0. You have to remember the fundamental commutation relation. Fundamental commutation relation says y px is 0. Okay, y py do not commutes. It is equal to iota h cut. Okay, and y pz 0, they commutes. So only y do not commute with py. Y commutes with y commutes with z, y commutes with x. Okay, y only position and momentum cannot be measured simultaneously. That's also in same direction. So x comes similarly, x and px do not commute. Everything other is x, pz, py, xy, xz, everything xx, everything is 0. So now, since here all the things commute y, z, y, px, so this, if I solve this one, this should come 0. So it will come 0, 0. Now let us do it y, lz. So y, lz. So just now, how do I write y? I write y. Z, how do I write? I start with the x, then py, then y, then px. Now here, y commutes with x, y do not commute with py, y commutes with y commutes with py. So this term is not important. I can leave this one. So only important term is x, py. And here also y and x commutes. So I can just simply take it out. Take it out from the bracket. So you have only y py left, and y py gives you iota h cut x. So position operator, angular momentum operator, you get again position operator. So y z is there, so you'll get x. If x y is there, you get z. Only you have to see the sign because they are in order y to z, so you get a positive sign. You get a positive sign. Now let us say y lx. Y lx, how do you find? Okay, you have a y. Lx is what? Lx is your start with y, then z, then z, then py. Y commutes with y commutes with pz, y commutes with z, y only do not commute with this number. So we can leave this one. So I have only y minus z py, and then again minus z is not important because it commutes with y. So only we have to check y py, and minus z y py is iota h cut. So this becomes minus iota h cut z minus iota. So y lx z will come remaining, okay, which is not present. Y lx z will come cyclic sign. Y x is reverse order, so minus will come. So minus will come. Same way we say if z lx Y Ly 0, Z Lz 0, X Lx be also 0. Now let us calculate Z Lx. So Z is there, X is there, so Y will come, and they are in order. So positive sign. Z is there, Y is there, X will come. They are in reverse order, so minus will come. So similarly, you can write for X Lx. X Lx will be 0. X Ly. X, Y, so Z will come, their order, so iota h cut Z, X, Z, Y will come, iota h cut Y will come, reverse order, so minus will come, okay? So X, Lx will be 0, X, Ly will be iota h cut Z, and X, Lz will be minus iota h cut Y. So all option A and B has been done. Now third option is R square. Okay, you have to check whether R square commutes with R square. You have to check commutes with angular momentum operators. So let us first check R Lx. So R is x square plus y square plus z square. Okay, so this can be written as a x square Lx plus y square Ly. We are doing for x only, and then z square Lx. Okay, now this we have already proved. X Lx is 0, so x square Lx will be also 0. And now y square Lx, how do we can write? We can write y Lx. I'm writing it as I'm using the identity. You have a operator, B operator, and C, A, B, C. So how do I write? I write here A, B, C plus I use A commutator C, and B will be here. If there is a B, and I'm doing with C, so this I can solve like this. So here this will be two. This bracket will give you two brackets, y Lx, and then y Lx. Y will come here. Similarly, here z Lx will come here, and then you have here z Lx. Z will come here. Now this you can write y Lx minus this is z y Lx minus. So minus iota h cut y, and the z will come. Similarly here minus iota h cut zy will come, zy. Here what will come? Here will come z after x, so I plus iota h cut z Lx y come, to iota zy will come. Okay, and then you have plus z Lx. So z Lx will give you iota h cut y, yz will come. So this cancels with this one, this cancels with this one. Okay. So you should remember yz also commutes. So you can yz also, you can write zy also. But here they are cancelling out, so no need to change zy yz. Okay, because minus is there, so this is completely simply cancelling out. So now this is equal to 0. That means R square commutes with the angular momentum operator x. Similarly, we can say R square also commute with Ly, R square also commute with Lx, Ly, Lz. That means R square commutes with angular momentum. Okay, R commutes with its component Lx, Ly, Lz. That means R square also commute with angular momentum. So they R square and angular momentum operator can have a simultaneous eigenstate. They can be measured simultaneously. So this is a very important result. So I'm stopping here. Thank you. We'll come some next problem.